Hello, welcome to Embedded Systems Technology for Beginners Part 4. In this class, we are going to learn how to write embedded C program from scratch using the Arduino C programming language. We have covered a series of lessons covering the basics of embedded systems, hardware-wise and software-wise. So this class we are kicking right straight into practicals. So what you are seeing here is our circuit diagram. These are circuit diagram that we're going to use. As you can see, an LED in series with the 330 ohm resistor connected to pin 12 on our Arduino. Then we have another set of LED with resistor connected to pin 5. Then we have a push button connected to pin 2. And then we also have a potentiometer on this side connected to analog input pin A0. Then we have our 5 volts connected, and then we have our ground. So I'll be showing us our hardware. Let's first of all take a look at our hardware. This is the hardware connection. As you can see it here, you can see this Arduino Uno you are seeing here. Then we have our LEDs. As you can see, we have our LEDs here. They also have a potentiometer. So this is our breadboard is connected to the board, so you can see the pins. So right as we've seen it on the circuit diagram, as we see it on the circuit diagram, the same thing, we have connected it here. So this is our 5 volt and ground. Then we have this is our pin 12. Then this is our pin 5 and our pin 2. So this is a push button here that is connected to our pin 2 here. This button, the push button that you are seeing there, this one, as you can see it. So this is the LED that is connected to pin 12, this one here. Then we have this one connected to pin 5. Then we have this potentiometer, as you can see, this connected to A0. And then we have our USB cable connected to the computer. The board is powered. So let's go right to our software environment. So we can see that we have connected our hardware to the computer. So let's go straight to our softwares that we need, that we will be using. Our software, one of the software we need is Arduino IDE. This is the Arduino IDE. So this is version 1.8.19. This is the last legacy version. It's 32 bits. The latest version is 2.0. So that runs only on 64-bit computer. So I advise, if you are going to buy your computer, make sure it's 64-bit so that you can run those 64-bit software. So the first things first, let's see how we will pair our Arduino board, our board that we have connected. So how do we pair it with this software? This software environment, we call it IDE, Integrated Development Environment. So this is where we'll be writing our program. So how do we pair our board up? So look at this. Come to your tools, come down, scroll down to boards. Look at this. So these are the Arduino boards that you see here. When you install the software, this Arduino IDE, all these are the default inbuilt boards that comes. The boards are the hardware, like the Arduino, like here This Arduino Mega, Arduino Uno. So see there are different versions. So this is, you can see, you now select Uno. Since we have Arduino Uno connected, you select Uno. Then after that, then you still go back to your ports. So how do we know the ports? So press your window logo and X on your, now running Windows 10. Then go to click device manager. Our Arduino board communicates with the computer via serial ports. So we come, so you can see here we are seeing Arduino Uno on COM4. So take note of that. So that's how you know which COM ports our board is. So we'll go back to our tools here, come down to port, and you see you select Arduino. So that's how you pair your board with your PC. Then look down at the bottom right, you can see Arduino Uno on COM4 displayed. So that is how you set up your hardware with the software. So you see, so let's just explain some of the few things you need to have knowledge of. For those of you who are new to computer, this you are seeing right here is called serial monitor. It's a serial monitor. Now when your board is connected, as you can see, Arduino Uno on COM4, when you click on this, now this is an interface where you receive information from your Arduino board on this environment here. Then here is where the Arduino board can receive information from the user. So it's a serial communication. So that's what we call the serial terminal. So we have this inbuilt on our Arduino software. Although we still have some other free serial terminal programs online which you can also download and install. So let's check. I should have installed one of them. Let me check my Windows. Okay, let me quickly install one of these programs, which also we will be making use of it. So let me quickly install it. It's good to have a collection of software so that when they are needed, you install them. So this one I use mostly is called Termite. Where is it? Okay, this is it. So I'm going to install it. So it does the same job with this serial monitor. So I'm going to pin it down here so that I can easily access it. Pin it to the taskbar so that once I click on it, so it opens. So you see, so we'll also be using, so I use this mostly. Let me set it up. So I can decide to use this or this. So if I don't want to use this one inbuilt, I can decide to use this. So I can make it to stay. So we'll be using this also in our practical here. So let me close. So apart from this Arduino IDE, what are other software that we need to have? Another one is Proteus. This is Proteus that you see. So this is the version I'm using. You can also have this installed on your PC. I use this for designing this diagram. Let's go to the file. So this is a very good software you need to have on your computer if you want to learn embedded systems. The software is not just for simulation. You can design circuit boards with it. So you see, so this is how I use the software for designing the circuit that you see here. I will be making tutorial for this for those who want to learn how to design circuit and also simulate circuits. I'll be making in upcoming videos. I'm going to be making it. So this is one of the also a useful software you need to have installed on your computer. Then there is another one. This might not be necessary for the beginners, but for those who are already familiar with computer programming, this is Microsoft Visual Studio. So it's Microsoft Visual Studio. This is the version I'm having. So these are the programming languages it supports. You can even see Arduino. I've installed extensions, so I'm also will be using this also to write our Arduino programs. So you can see Arduino boards being selected from here, and then also it's ports connected. So let's start right away. We have set up our hardware. We have set up our hardware as we can see on this image, the camera showing it up there, our hardware connected. So first things first is what we can decide to start our programming from here, or we can also use the other IDE. So first things first, the first thing before you write any program, this part you are seeing here is called the program header. It's not compulsory, but it is necessary. The file name, you have to give your file a name. So this is the name. I call it digital IO. That is, IO means input output, then also analog input output, which is PWM. So the file extension, you know, the Arduino programming language is based on C and C++. So we know the extensions of C source file, which is .c, and C++ .cpp. So the Arduino created their own file extension, which is .ino. So once you see this file extension on any computer, you know that this is an Arduino source file. So this is very important, the file name, and then the author, you writing the program. This is my name, and then the date today is 29th December 2025. Then the targets, our target hardware is Arduino Uno, or also Arduino Nano. You call it from then in brief notes. Embedded System Technology for Beginners, Part 4, how to write Arduino C program from scratch for beginners. So it's good to put this up if you'll be sharing your code, or it's good. So this program header, just like as I've said, it's not compulsory, but it's needed. So by default, when you start your Arduino program, you see this void setup and then void loop. So these are functions. Function is simply a group of code commands that you're going to write in here. You understand? They are commands, and then you give the function a name called the setup void. It means that this function, when we call it, it's not returning anything. You just call it and it runs the programs. You understand? So The same, then coming down here, loop, it means this is where your main code is going to be running, what your microcontroller is going to be doing, when you power up your board. Then here we can include some other files like header files, libraries, and then variables. So inside this setup is where we configure your microcontroller. Before you make use of your microcontroller, there should be some configuration that we need to do on it. You cannot just start issuing commands to your microcontroller. So we will be using the Microsoft Visual Studio for our coding. So let's go to our Microsoft Visual Studio. So we'll continue. So we're going to be using this for our program. So now let's go back to the Arduino IDE. Take a look at this. You see this here, verify. Verify means compiling. Now when you write your code, compiling means you are converting your instructions into machine language that will go into the brain of the microcontroller. So the Arduino system, they formulated their own way of naming their things. They call it verify. It simply means compile. Then this one is upload. You click on this, it will convert the code that you have written into machine language, and then it will upload it to your hardware. You understand? Then this, if you click on it, so it's as you see, if you click on a new window, will be opened. Then this one is to open your existing all these are codes I've written, so you want to open them. So that's just the few things you need to know about the IDE. Then we have the serial monitor. These are all the few things. So I won't be using. I'll use this other one that we have here. So yeah, the same thing. If you click on this, it's going to compile. Then if you click on this, it's going to compile and upload. So we have selected our board here and then the COM port. So what are the first things we need to do? Number one, we'll be making use of this library. So include streaming so it's a now anything I write in front of this forward slashes is not going to be it's not part of the code. I'm just explaining what this statement, that command is saying. So this is C++ output streaming library. So a library is simply external files that you invite them into your code during compiling to add additional functionality. So that's what libraries does. So we'll be using, although this library is not compulsory, but how do you install this library into your Arduino IDE? So this is how you do it. When you're online, make sure you have a good internet connection. Come to Sketch. Sketch simply means your source code. The Arduino, they call their Sketch, so it simply means source code. Then you come down to here, include library. Then when you click on library manager, make sure you are online before you do that. So you wait for a while, then you type in that library and the library pop, and then you install it. So that's on a simpler way. So is C++ output streaming lab. So we'll be using it. So first things first, we are going to do this. Now in the setup here, this is the first thing we're going to do. We're going to set up our serial. You see this USB that you see here, USB connected. It's a serial communication. So we're going to set up our serial communication by typing this command, serial.begin, then bracket open, 9600. So what is 9600? This is our serial communication speed. So we call it baud rate. So the serial communication speed. So let's go back to our Arduino IDE. Let me show you something. So now let's click on this. If you take a look at this, all these are the speeds that you can select from it. So whichever one we are using in the program should be the one that we select here. So in case we want communication between a microcontroller and the computer, so that what this speed that you see here. So now this is what we're going to do. We're going to tell our microcontroller to send message to our computer, the text message string. So this is what we're going to do. So we say welcome to embedded systems technology for beginners. So you see, so this is a C++ style. So you see, so let's say wait for a little. So delay. So this is this delay means we have to wait for this 2000. 1000 here is 1000 milliseconds, which is also the same thing as 1 second. So this is 2000, which is the same thing as 2000 milliseconds or 2 seconds. So I'll wait for 2 seconds. So that's what it means. So so what we are just doing here is sending message digitally to computer, a text. What we are now, if you see these double quotes, it means that this is text. So we refer to it as string. You understand? Now, if you don't have this library, installed, this is how you're going to do it. Now, take a look at this. I'm going to do something here. This means I have deactivated this line. It's no longer a code. Just like I have cancelled, I've deleted it. So I've cancelled it. So it's no longer a code now. It has become a comment. No, anything, things you see written in front of this double slashes, they are not part of the code. It's just comment. So if you don't have this library installed, so this is how you do it normally. We have serial.print and we also have serial.print line ln. So this print is going to be sending the message. It will be going horizontally. You understand? Then when we add this ln, is the same thing as you press enter, it will go to the next line. That means end of line. So this is how you do it. So let me copy the whole of this. So this is a normal way we do it in Arduino C. So you see, so now let's test, let's upload this. So how do we upload this? So I'm going to click on this. So if you look down here, it will it will be compiling it. If you look at this indicator here, it is compiling it. Then here, information concerning the folder where our file that we're working on is. So it's compiling it. So we look at it, it's uploading. It's uploading onto our board. Upload has finished. So let's go to our Arduino IDE. So I'm going to click on this serial monitor, and you can see it. You can see it. So we have just written our first program. So the microcontroller just sent message. Now each time on your Arduino Uno board, each time you press this serial, it will reset the board. The board is going to reboot. If we check on our board here, you can see a push button. So let me press that push button and take a look at this place. You can see it will restart. So you can see, so digitally we have sent message to our computer. So this is where message coming from the board will show here. So we have written a program and it's running. So this is what we're going to do now. Now these are what we're going to do. Digital inputs. Digital outputs. Analog inputs. Analog outputs. So which is PWM. So these are what we're going to be covering in this class. So let's start with this. We can start with any one of them. So we're going to start with digital inputs. So let's go back to our circuit diagram. Look at this push button here. Look at this push button. The push button is simply a switch. When pressed down, it closes the circuit or opens the circuit, and when it releases, it goes back to the default state. So this is push to make switch. So you see, so one terminal is connected to ground while the other terminal is connected to microcontroller. Now normally we're supposed to connect a resistor on this pin to 5 volts, but we don't need to do that because this microcontroller here on the Arduino Uno, this microcontroller that you are looking at there, it has resistors inbuilt. We refer to them as pull-up resistors. A pull-up resistor is a resistor that you connect to an input pin, or either could be an IC or transistor or whatever circuit, then up to a positive power supply to pull that pin high. Now we are dealing with digital. Digital is 1 or 0, on or off. Something is there or it is not there. So you see that's digital. So you can see. So we are using the push button. So when we press these push buttons, it's just like your computer keyboard. The buttons that you see like this are computer keyboard that we are seeing here. The computer keyboards. So these buttons that you are looking at, they are all push buttons. You press them and the computer will react. They are all push buttons. So you understand. So those are all push buttons We have them on our electronics gadgets, various electronic gadgets that we use. We have those buttons. Uh, so as you can see, we have the push button here. So you see, we have the push button here. So we have the this is a push button that we have right here. So you see, this is a push button here. So we connected this push. So when we press this, how we want our microcontroller to react. You understand? If I press the window logo button on this computer, you can see this computer reacted. Let's press the window logo button again. You can see my computer. So we are going to do this. Now me pressing this button now is digital input. As you can see, computer reacted. I press the button again, computer also reacted. So that we're going to do the same thing on this button. So we're going to press this button down and then tell our microcontroller to sense that this button is pressed, then send message to the computer, the state of the button. So this is how we're going to do it. So now let's look at our diagram again. Pin 2, take note of that, pin 2. Now we are going to be naming these buttons so that okay, let's call this one button 1. Let's call this button 1. Let's call this one LED 1. Let's call this one PWM LED, and let's call this pin here port pin or potentiometer pin, whatever it's called. So you can see. So so let's go right to our program. So this is what we're going to do. This is how we give names to people have nicknames. So instead of calling pin 2, we're going to give names to it. So this is how we do it. So we're calling it, let's say, this button 1. So this means button 1 is connected to pin 2. That's what it means. You understand? And there are many ways you can also do this. You can also do it this way. You can also do it this way. Any of them is correct. So you understand? So take note of that. So you can also do it this way. So let's go this way. Now before I do something, I like doing this in my programmings. I like to put this kind of indication so that I can be separating so that I can separate and be seeing what I'm doing clearly. So it helps me. Yes, so if you see most of my programs, I usually do this so that I can be seeing this, so that I can be demarcating this and this, so that I don't make mistakes, so that I can be seeing these ones clearly, the functions. So it helps me. So that's the reason of doing this. It's nothing else. It's just my own style of programming. So every programmer have their own style. So now it's not for a unique command. You don't need to be doing this. But I'm just doing this just to like put a line so that I can be seeing this clearly. You understand? So that I will not be made. That's just the purpose of it. So now we have told our microcontroller that pin 2, we are renaming it button 1. So this is what we're going to do. We'll come down to our setup. We need to configure the pin. So this is how we do it. Pin mode. Pin mode. So instead of pin 2 like this, instead of doing it this way, So instead of doing this way, we don't need to write 2 there again because we have given it name, so which is button 1. So you can see input pull up, so it means we have activated activate input pull up. So because we are using push button, it's connected to those pins, so we are now without the, if you are connecting resistors externally, you can remove this, do it this way. It means input. This is how you configure the pin as input, but make sure you connect pull up resistors. But since our microcontroller have inbuilt pull up resistors, we don't need to put them, write it this way. So that's what this line of command means. So you can see, it. So now we're going to do something here. So we are going to tell our microcontroller to put a listening ear on this button, on this pin, that's on pin 2, to listen to pin 2, to scan pin 2. You understand? Now we are going to also do something here again. We are learning programming, so we are going to do something here. Let's say we want to your computer memory, you want to like reserve some certain space of the memory. You now give it a label. You'll be using it for storing something. You understand? So here we call it declaring variables. So we're going to declare a variable. That means we are going to create a space. We're going to store the value of this button that we're pressing. Now take notes, the value, it is either 1 or 0. It is either on or off. It's either high or low. So we're going to call this bool. Now boolean in mathematics, in logic algebra, boolean, they're just something true or false. You understand? So you just store 1 or 0. So we're going to call it button 1 value. So let's call this button 1 value. So which means we have allocated space in the computer memory for storing a type of data, which is 1 or 0, which is true or false, which is high or low. The state, when we press this button, is going to be stored. The value of the button is going to be stored here, either 1 or 0. So this is how we do it. So now how do we tell the microcontroller now to scan the button? So this is what we're going to say. We're going to say our button value is equals to digital read. Which pin are we reading? Our button 1. So you can see, so it's just straightforward. So this is how you read. So this means read or scan. Either you read or scan button 1. So to check, find out whether it is being pressed. Then as you scan it, send the state of the button to your computer. So let's go back to this. So we're going to be using this style of so let me cancel this. So we're going to do this thing this way, serial. So I've checked the state of the button continuously. It's not like the way our computer is scanning the whole buttons on the keyboard. So send messages. So I'm going to start it with a sentence, button value. So our button value is equals to, or we could just make it something this way. So you see, then our so what this means, end of line. is the same. It does the same thing with this print line that you see here. So this is a text, and this is a value. So if you're printing, sending this in, so using this in this C++ style is very easy to use. It's just straightforward. So you see, so now if I'm going to do this in this way, print line, I'm going to say serial.print this, and then I'll now say serial.print line this one. So you see, so let's upload this to our board. Now if you check your board very well, even the uploading, you will see some lights will show up on it. There are some lights here. Yeah, when you're receiving data from the computer, you're going to be flashing. So program is compiling. So remember, we are doing digital inputs. You know, we have added something to the program, so the size will increase gradually, and then the compiling time also will also increase based on the size of. So it's nice uploading. So if you check some lights, so you see some lights flashed. So you see, so you see, now we forget to do something here. Let's do some correction here before we go check. So we need to put in a little delay, otherwise this will be running very fast. Let's say like 200 milliseconds. 200 milliseconds. So this is say wait for 200 milliseconds. So you see, so let's upload. So every 200 milliseconds it will be sending the state of the button to the computer. Now one thing is with this programming, the faster your computer is, the faster you're compiling and uploading. So let's go to our Arduino IDE, and let's bring this down. Okay, so let's go to our Arduino IDE. There we're going to open our serial monitor. Let's see what is showing up there. So you can see this means that the button state is high. So let me press, I'm going to press down the push button. So you see, what do you see? 0. I'll release my hand. Let's take our board back. So let's see something. So this is in real life. So you can see this light flashing. It means that the board is sending information to the computer. So yeah, my push button is here. I'm going to press this. So why now I've pressed the button down, so you are seeing this thing in real time. So you are seeing it. This 0 means that I have pressed down the button. I'm releasing it. You can see 1. I'm pressing it down again, so you can see I'm releasing it. You see 1. So that is, we have just done digital input. So let's press the window logo button on our computer. So you can see computer reacted. I press the button, see computer. So the same thing, I press this, and they might have this. So we have learned how to write a program to read a push button. To read a push button. So let's go back to our, so we have successfully written a program to be able to read our push button. So let's make the program more, so let's see, go back to how we started. First in this library. Now let's come back here. Now, assuming you don't have this library installed, if you don't have this library installed now, this is what you are going to do. Instead of this, you can do it this way. Let me just copy this. Let me copy this and edit it. So this is how you do it. Serial.print. So this is how you do it. Serial.print line. So this is a standard way we do it in Arduino IDE. So you can Arduino C language, I mean. So this is how we do it. So you see serial.print is going to continue with this. So after printing this in, you are ending it with a line. So it will do the same thing with this. You understand? So let's upload it and let's take a look at it. Oh, it has uploaded. So let's still confirm it, check it, make sure. Open our serial monitor. So you see it's working the same, exactly the same thing. So so let's press the push button again. I've pressed it down, I've released it. I've pressed the button down, I've released it. So your microcontroller can now sense something from the external, from the outer world. So that's how you can write your Arduino C program. So you see, so these are very important. So we are doing digital input. So our push button, pin 2, we rename it button 1. We will take a memory, we label that memory with a name, and then tell this C language this type of variable that we are storing. This bool means that is 1 or 0, true or false, high or low. So each time we press this button, the value will be updated here. So which is what we have seen here. So as we read, take note of this, digital read. Memorize this command, digital read. What are you reading? Pin 2, which is the button. You understand? So before using this pin 2, what did we do? We first of all activate the pin. Since we are using it for push button input pull up, so take note of these commands very well. These are the very important. Then how do you set up your serial communication? Serial.begin. These are the important things. You understand? Then sending message to the computer in the Arduino. Normally, this is how you do it. Send a text message. Then what did I say? If you have this library installed, with this library installed, You can also write it this way. You understand? So I provided two methods we write the same thing. You understand? Then we want to wait a little for like 2 seconds. Now this code run once. Now when you power your microcontroller, it will check, the microcontroller will check for what it's in its brain. It will run them line by line. It will check this, it will check this, it will load this into the RAM. Just like our laptop computer, they have RAM. Our microcontroller is also having everything: RAM, ROM, CPU, everything is in there. We have covered all that in our previous classes. So if this is your first class, please go to my YouTube channel and watch my previous videos. But before you do that, make sure you subscribe and also share those videos so you can watch my previous video. We have covered all that. So now here, loop, void loop. This means this will continuously as long as the microcontroller is powered. Now let's use the other serial. Now I always like teaching people alternative way of doing this thing. If you don't want to use the serial monitor in the Arduino IDE, you can see this. So you can see this program. So it's still doing the same thing. So let me press the push button on the board so you can see it. So this serial monitor program is also another program that I also use also. So you see, so I can even minimize this and put in here, so you can see. So whatever is happening in the microcontroller is sending to the computer, and I'm seeing it, so that for us to know if our program is working. That's why the serial monitor is very important. This serial terminal is very, very important. It's for debugging. You understand? Debugging is simply finding errors in your program and fixing them, or to check what is going on in your program. You understand? So it's a very useful utility. So tells us what is happening. So now we have confirmed that our code here is working, and we are able to do our digital. So we have completed this part now. You understand? So we have completed this part, our digital inputs. So we have covered this. So the next thing we are going to do, we are going to cover this, and then we will close the lesson for today. The next lesson we are going to start with analog input. So let's quickly do this digital output. Digital output. So let's go back to our circuit diagram. Let's go back to our circuit diagram. Which of the pin are we using for our digital output here? Pin 12. So pin 12. So let's go back to, so we are going to add our pin. So let's call it LED 1. Let's call it LED 1, and it's on pin 12. So take note of it. This one is an input pin. Input. This one is a digital input pin. So we configure this one as digital input pin. So this one now, you know that it's going to be an output. So it's digital output, digital output pin. So take note of that. So we're going to configure it digital. So how do we configure it? Pin mode, LED 1. So what you just simply do here is output, as simple as that. So you see, so that's how you activate digital output. The pin you activate is as digital output. So you can see. So that's also what we do. Now let's go back to our computer again. Now pressing a window logo, what do you observe on my computer? You can see this. Let's assume now this is an LED. Now LED is to light, show light. And then let's press the window logo button on our computer now. So this is what we want to simulate. Simply what this. So pressing it, it will going to, when we press this push button, we're going to tell our microcontroller to activate this pin that the LED is connected to, so that there will be power on the LED. And then when I press this again, so let's do out. So if we say digital read for reading, then the other one will be what? Digital write. No, it's very simple. So this is what you're going to do. So the opposite of digital read, the opposite of this digital read is digital write. Digital read is you are doing digital input, they are reading from a digital pin. Then digital write, you are writing to a pin. That means you are giving digital output. So now we're going to tell our microcontroller, if this button is pressed, turn on the LED. This is what we're going to do. If button 1 value is low. Now this is not English language, this is computer programming. You understand? So it's not English language. So this is the language of these microcontrollers that we are doing, not the language of a human being. So this is what it means. The microcontroller, we are telling the microcontroller that if this button is pressed, that's what it means. Because from our diagram, from our circuit diagram, if you are pressing this and you are creating a short circuit to this pin, which is going to be 0 volts, which is going to be 0, logic 0. But without the button being pressed, it is on logic 1. That's why it was showing 1 on our serial monitor. So if this button is pressed, and so what should happen? Turn on the LED. So that was digital write. Which pin are we writing to LED, to LED 1? What state is it, off or on? So when you are turning on the LED, you say high. So you see, so if the button is pressed, turn on the LED and then send message to the computer. The LED is on. So you see, send message, the LED is on. So let us upload it, and now why another possible errors that you might encounter when you are uploading, make sure the serial monitor, any serial monitor program that is accessing the serial port should be closed. Otherwise you are going to have some errors during uploading. So make sure the serial monitor is not running, make sure it's closed. So okay, our program has uploaded. So so this is what we're going to do. Open our so let's use this one here. Open our serial monitor. So let's check. So while let me press the button. So take a look at so you can see the LED here. You can see the LED is on. The LED does that way, it plays too bright that your camera can. So this LED here, the LED is on. So you can see it. Where my hand is, the LED is on already. So you can see. So the LED is on. So you see. So that's we have done digital output. Now let's make our program more sensible. This is what we're going to do. So now you see this instruction here is based on this. So we want to write something. Let's make it this way. Now okay, let's cancel this. So let's say something here again. Now let's make it this way. So now we're going to say something like this. If digital read, you do know that we can also read this pin to find out if it is on. So that's what we want to do. We want to find out our microcontroller. I want to find out whether if this pin is high. You understand, the pin that the LED is connected. So this is what we're going to do so that it will know what message to send to the computer. So we say if digital read LED 1, if the pin is high, that means if the LED is on, what should we do? Send message to computer. This message you are seeing here, this is where we're going to make use of it now. Send message to computer. The LED is on. They will come down here and say else. Else, let's just make a copy of this. Else, we can also arrange our code this way. Else the LED is off. So you see. So you can see. So now you can arrange your code this way, is still the same thing. If you arrange it this way, you understand. So you can take it off. If this condition is true, send this message to the computer. Yes, because if this condition is not true, it has to be false. You understand? So let's make this thing to be okay. Let's just leave it that way. So let us upload this. So we are flowing now. So this is digital input. From here, digital input, you turn on the LED. You understand? Then here you are checking. It's just like what we have here is just like the mirror you have in your car. Let's click this while it is uploading, while I do some explanation. You understand? This one is just like a mirror that you have in your car. It's just like a feedback to check what, okay, you have the microcontroller now did digital input and it detected. You have given instruction here. Once this button is pressed, turn on this LED. The microcontroller wants to check actually is the pin high. Because if the pin is high and the LED is connected correctly, the LED is going to show some light on it. You understand? So it will check to know what kind of message to send to the computer. If it confirms that the pin is high, where the pin, the LED is connected, you know that the LED is on. Then else, if the pin is low, it means the LED is off. So let's go to our serial program and check. So you can see the LED is off. So let me press the push button. You can see. You can even see it here shining here. I've turned on the LED. So now let me press the button again. It still remains on because we have not instructed the microcontroller now to turn it. So how do we do that? Now let's come back to our Windows, our computer keyboard again. Press the Windows logo on your keyboard. You see computers doing this. So this is just like we have turned on the LED. Now press that Windows logo button again. You can see that the LED is goes. So this is what we want to do now. So we are coming down here now. Now this is how we're going to do it. So I'm going to cancel this. Now this is how we're going to do it now. So let's make a copy of this. So this is what we're going to do. So this we're going to remove it. Now you see this, your shift and your number 1 key on your computer keyboard. You see this exclamation. This is exclusive or. Then we're going to now do digital read now. So then we're going to now do digital read. We are writing and reading. So you see. So now we need to add something again, so a little delay for like let's say 350 milliseconds. So you see, so this one is just I know push buttons, they have a problem that is associated with them bouncing. So this is the bounce delay. So that was that function of that, the weight, that delay that I put here, the bounce delay, for those noise to settle down before the microcontroller is executing action that we want. So now we have modified our code. Now what this command here does is to flip the pin. That means either high or low, on or off. Each time we press this button, it's going to check if this at its writing is reading the pin again at the same time. Notice an output pin to check whether if the pin was previously on. Let's click to upload. If the pin was previously on, it's going to turn it off. You press the button again, like your power button on your TV. You press the power button, it will on the screen, power will come on the TV, turn on. You press that power button again, it will reverse. So it has so that's exactly the action that we're doing here. Like your DVD player, you press the eject button, the tray will open. You press that eject button again, the tray closes back. So our upload has finished. Let's open our serial monitor. So our LED on now. I'm going to press that button. I've released my hand. You can see the LED is on. I'm going to press the button again. You can see I release my the LED is off. Oh, we have successfully done digital input and digital output. So you can see. So how where is my camera's gone? Okay. So let's check this thing again. So that so you can see. So this red LED that you see in here. Let me zoom this so that you see it. So you see this red LED I seen here is the pin. So I'm going to press the push button. you can see the red LED is on. So I'm going to press the push button again. You can see it is off. Press the push button again, it's on. I press the push button again, it is off. Oh, so we have successfully done digital input and digital output. So before we go, let's summarize our program again from the beginning. What did I say? This is what program header. This program header. It is not compulsory, but it is very important. The file name, the author, the person writing the code. If you are the one writing the program, you put your name. If it is somebody else, you can reference the person. Then the dates. Today is 29th December 2025. Then you target, so that if you show somebody this code, they will know, okay, this code is written for this hardware. Then a brief note about what the code is going to, what is it. So it's just a beginner program. So these are the things I said we will be covering. We've done this digital input, and then we have also done this. So we have covered these two in this our class. So this ones here will be covered in our previous class. So let's come down and just go through for the last time. What did I say? This library, streaming library for, that's a C++ output streaming library. It is important, but if in case you don't have it, there is no issue. So this digital input pin, then this we are using that digital output pin. So we call this one button 1, we call this one LED 1, and then a variable to store the value of the button. This one you don't need any, the LED don't need anything to store it, since you are just writing into a pin. Then what do we do? Come to our setup, activate this one for the push button input pull up. Then this one pin mode output. Then what do we do here? Set up our serial communication, enable it. Then there are two ways I said you can send information to your computer from a microcontroller serially using this way if you have this library installed. But if you don't have this library installed, you do this way. This is a Arduino way, that the standard way we do it in the Arduino programming language. Then wait for, it's just like welcome message. Once you powered, press the serial monitor to open. So then coming in here is where the loop, where your program continuously to be doing its work. So what did it do? To be scanning this push button. Scan the push button, and if the button value is low, it means that it is being pressed. So what do we do? Firstly, we did this just to turn on the LED. But in this case now we have changed it to be flipping the LED. So each time we press this button, make sure there should be a little delay. It's very important. If you don't put this, you're going to confuse the microcontroller. Take note that a human being would think you are pressing the button once, but according to, as far as the microcontroller is concerned, because our board is also vibrating, so the microcontroller is going to detect that vibration multiple times. So which we don't want that. So to avoid that, solve that problem, just use this software way to do it so you can see. So then this one, to flip the pin, check the pin. If it were previously on, turn it off. If it were previously off, turn it on. That's what it means. Reading right now, reading the output pin. Then we can send some values, some information to the computer. Then here, check the output pin, whether it is on. If it is on, send this message, let this on, else, and then little delay. So so we'll be ending the class here. Thanks for being part of this class. Please do your best to practice if you just watch this lesson and you didn't do anything, I don't think you could never. This is practicals. You understand? Practice makes perfect. So try and get your board, your Arduino Uno, or even your Mega. Our previous classes will be also be programming this in with Mega, and then your breadboard. So you can see, so we have been able to demonstrate digital inputs. You can see digital inputs, digital output. So we have been able to do that. So please do your best to subscribe, and don't just sit down there. Make sure you read from books, textbooks, get your board, and uh, practice. So goodbye. Please share this video to a friend, share it to your Facebook groups, and also subscribe, so that as many watch this video, they'll benefit from it. Now take notes, this is not what you learned from your schools or universities and your polytechnics. I don't think the lecturers will have that time to be sitting down and be teaching you stuff like this. So this is the only opportunity you have to be good in this. This is not academic knowledge. So in school there, you go there to acquire mostly what we see these days is just purely academic knowledge. So you cannot use that academic knowledge and come out from the school and say you want to design an embedded system. It's not possible. You will have to learn it. You will have to learn it. I learned it this way, so that is why I am also teaching you. So if you really want to know this thing very well, go and practice this code that we have done here, that we have developed here. We have written it. As you can see, we wrote our code from scratch. So, and then this thing again, please take note of this information. I usually hear some guys that will say, no need of you to go and learn programming, AI is going to do this. Please don't listen to such kind of informations. AI is good. AI is useful. Use it to learn. Also, even me, I also use AI to learn a lot of things. But there are things you should do by yourself. Just like this code now that we are doing here now, it's not AI that is writing it. I'm doing writing it with my hands myself. So that's how you do learn. You don't go and tell AI to write code for you. No. You learn to write code by yourself, so that tomorrow you can be able to sit down and develop something. So there are things AI will not be able to do for you. You send AI to write code for you, and you continue that way. You are not going to learn how to write program on your own. You will just be depending on AI. There are some real life things you're going to be designing. Those code AI is going to write for you, they are not going to work. So take note of that. So the best thing, learn to write code with your hands, type codes yourself, and then see it running. That's by doing that, you are going to be memorizing the commands, like the commands that we see here: digital read, digital write. You see, serial.begin, serial. So you can see. So if you had to use AI with doing that, you won't know them. But as you are writing it in yourself, that's how you know. As you continue doing that, that's how you very good in programming. You can also use AI to learn. Ask AI questions concerning embedded systems. Take note, it's not everything that AI will give you that is 100% correct. So take note of that. So learn how to do things by yourself. Don't be relying on AI for everything. So we end the class here. So thank you. Have a nice day.